In this video, we're going to look at one of the Palisade models. All of these models are available through the link that you find in your course. And this particular model, we're looking at advertising in different media as the problem set up. One of the reasons I've chosen this is because it has some familiar uncertainty aspects, but it also adds a neat twist by allowing us to use Risk Optimizer. Let's have a look at the model. We begin as a company that is trying to advertise, and our objective is, as you see down here in this highlighted cell, our objective is to try to minimize the cost per exposure in our advertising campaign. So we begin up here looking at 10 different media. These could be magazines, websites, or any other kind of media that you can imagine, and each one of them has a different cost. Now, what's uncertain, what we don't know for sure, is how many people will our ad reach. And so you see for Media 1 here, we are estimating non-parametrically how many people we will reach, between 60 and 90, most likely 70 people. There's another aspect of this that's uncertain, and that is, of those people that we reach, how many are in our target audience? And here you can see for Media 1, we've estimated it's between 20 and 60 people, most likely 40%. There's also another value here, the exponent, and I'm going to say, just hold on that for a moment. I'll explain it when we get down to the calculations below. Let's move down there now. Notice that we are going to place 20 ads. So we are trying to figure out which media should we place those ads in 1, 2, 3, 4, 5. And if we had precise numbers, this would be a relatively simple optimization kind of problem. But because we have uncertainty, it becomes a little bit trickier. So let's just examine this Media 1 row. In Media 1, notice in the yellow cell, we are looking at 2 ads with Media 1. An ad costs $480, so the total is $960. Now we move over to the simulation piece, particularly in here the number of people reached. Although it looks like a precise number, you'll notice it actually comes from a PERT distribution. And the PERT distribution gets its values from D, E, and F4. That would be up there in row 4. These are the 3 numbers that would define this particular PERT distribution. And every distribution in this column is defined in a similar fashion. There's the PERT distribution using these 3 numbers. Now if we scoot on over to the right to the percent target, you'll notice this is also a PERT distribution, and this happens to be using these 3 numbers up here. Okay, so we have values here, and you'll see that these values, let me turn on our simulation, these values are the values that we don't know. That makes deciding who to advertise with and how much that much trickier. What we're after is this number of exposures, and this is fairly simple. It begins with 79,000. You take 41.6% of that, but we've not looked at this effect number yet. If you look up in the function up here, you'll see this says go to cell C17, which is highlighted here in blue, it's 2, and raise it to this power over here, 0.84. So this is where the exponent comes into play. And the exponent's basically there to say that the second ad is usually not as effective as the first ad. So the lower the exponent is, the less effective a second ad is. So we get our total number of exposures by multiplying this times this times this gives us our effective number of exposures. There's the cost, and that's one bit of input. So down here, we add up the total exposures, and we have the total cost over here, so we can easily calculate the cost of exposure. Here's the tricky part. Because these values are uncertain, it's not so easy to figure out how many ads to buy with each media. This is where Risk Optimizer comes into play. Risk Optimizer is only available with the industrial version of Decision Tools Suite, So in your student version, you are not likely to have this. But we'll click on Model Definition, and you will see a window pops up, and it says, we are trying to minimize cell G30, which is the cell that I've highlighted, $22.48. And we have identified a range of cells that can be adjusted to do this. We've basically said, use those yellow cells, C17 to C26. They have to be equal to or greater than 0, less than or equal to 5, and they can only be integers. I go back here and we'll look at the settings once, and this is saying they're going to do 1,000 trials. A trial is a combination of adds. Now we have a couple of rules, as you just saw a minute ago, that it can't be less than no adds, can't be more than 5. So what Risk Optimizer is going to do is try a variety of adds. It's going to try 1,000 different combinations of adds. And while we have our iterations here set at 500, it's going to do an iteration of 500 for each combination of adds. So now we're going to go back up to Risk Optimizer. We're going to hit the Start button. You're going to see the familiar At Risk screen come up, and there is a 500 adds, 500 calculations. And if you look over into the lower left, you will see the Risk Optimizer progress. It's on trial 37 of 1,000 right now, so it's going to take a little while to get there. But notice this. It's saying that so far the best number it's identified, the best cost is $19.39. It started off with $22. If you can look at the yellow cells right now, you'll see they're changing. For the moment, it's evaluating 3 from number 1 and 1 from number 2 and 5 from number 3 and so on. So it's going to do 1,000 trials. So what I'm going to try to do here is to pause this and come back when we're closer to finished. So I join you once again as we're counting down. You can see this has been running for over 4 minutes. Just to review, what At Risk is doing for us is 1,000 sets of simulations. We're doing 1,000 simulations of 500 iterations each. And it will use Risk Optimizer to analyze those results and identify the best advertising strategy for us, given the uncertainty that we're dealing with here. So once again, I don't expect that we're going to master all of these features, but I would like you to have some idea of what the software is capable of and what risk assessors are doing, because there really are some great tools out there, and it's good to know what you can grow into. So we're just about done here, anticipating results in a moment. Let's see if we can close this. Whoops, let me go here first. And we'll see our summary says the best we have is $18.86. And this gives us the combinations of each. So let's click OK, and we'll have a look here. And so what we have is the very best strategy. That would be 3 adds with media 1, 5 with 3, 1 with media 4, 1 with media 5, 5 with media 7, and 5 with media 10. And going back to our Risk Optimizer, looking at our summary, we find that if we use that combination, we can reach each customer for $18.86. That's the best deal that we've got going. So this becomes a very neat tool.